So here's some solutions to a question from the 2010 AB exam, Form B. Problem number 2 here was a calculator question, so we'll definitely be making use of the graphing calculator several different times as we try to produce the solutions for this. But the problem statement tells us that g is defined for positive x's. We know that when x is 1, the function value for g is 2. We know the derivative of g, and we also know the second derivative of g. What they ask us to do in part A here is they want us to find all the values from 0.12 up to 1 where the graph of g has a horizontal tangent line. So really what this question is asking us to do is to figure out where the slope of the tangent line is 0. And that's going to be where the derivative of g is 0. Now when the calculator's in play, this is really a pretty simple task. I have my calculator going here, and I have g prime already ready to graph. So I'm going to go ahead and I'm going to graph g prime. You do have to be in radian mode. I'm going to change my window. I don't need to be concerned with the standard viewing window on the calculator. I just need to be concerned with the portion of the x-axis from 0.12 up till 1. Right? I need to be concerned with this interval. I don't need to be able to see clear down to -10. So I'm just going to go from -1 to 1, right? A sine function is just going to go up and down between -1 and 1. So this should give me a nice detailed view of this graph. Find all values of x on the interval 0.12 to 1 where the graph of g has a horizontal tangent. When is g prime equal to 0? Well, this is a graph of g prime. This graph is equal to 0 at this x right here. This graph is equal to 0 at this x right here. So it seems like we're going to have two answers here. And you just have to take a minute or two to go through the 0 process on the calculator in order to determine what those values are. So it's going to take me a minute to click through this. I'm going to pause the video and I'll get the answers going here and we'll discuss. So I found both zeros on the calculator, and as always on a calculator for your response question, what you want to be in the habit of doing for the AP Calculus exam is either rounding or truncating your answers to the 3 digits beyond the decimal, and we would get these two x's as places where the slope of g is 0, and hence g has a horizontal tangent as the question asked. When we move into part B here, part B has to do with concavity. We want to know when the graph of g is concave down. And the graph of g is going to be concave down if the second derivative is negative. So we would need to know when g double prime of x is less than 0. Now, we have g double prime given to us. What you could do is you could try to build the sign chart for g double prime by hand the way you normally would. What you see I'm ready to do here though is I'm ready to graph g double prime, and I'm going to look at that graph and I'm going to try to see if I can determine for what portion of this interval that graph is less than 0. So I'm going to do this with the calculator as well. And so I have g double prime ready to graph here, and so when I have the window settings the same as I had them in part A, I get a graph that looks kind of like this. I don't really see a complete picture here because this graph has this additional component, so it's more than just a trig ratio. So it's going to go a little bit above +1, a little bit below -1. And so what I'm going to do is I'm just going to kind of change those pieces of my window. I'm going to drop down to -10 for y min and up to +10 for y max. And I don't really need to do anything with my x values. I still need to focus on this portion of the x-axis, so I'm just going to leave my x's as they are. And when I graph, what I see is my graph seems to kind of drop down here probably. It hits the x-axis there, and then it seems to hit the x-axis again here. Now I don't like the fact that this piece of my graph looks pretty vertical, so I'm going to just kind of stretch my y-axis out a little bit further. So I'm going to go back into my window settings, and I'm going to change this to -20 just so I can see down a little further and then up a little further, and that should give me a better feel for what exactly is going on. Yeah, the graph is really dropping pretty rapidly on this portion of it. Crosses the x-axis here. It's negative between this x and this x, and then it's positive from there on out. So what the sign chart for g double prime should look like on the interval from 0.12 to 1 is something like this. We're going to have the sine of g double prime between this x and this x. It seems like it would change once here and then change again right here. So I'm gonna put two potential split values in my sign chart, and I'm gonna have to do some work on the calculator. I want to know when the second derivative, which is graphed right now, is 0. The second derivative is 0 at this x, the second derivative is 0 at this x, and the second derivative is negative between those x's, and it's positive on the other sides. So I'm going to pause the video one more time, do some work on the calculator to find what those zeros are, and I'll toss them onto the sign chart and we'll draw the appropriate conclusion. Okay, so I took a minute to find the zeros. The 0 right here was at 0.129. The 0 right here, you can still see it on the calculator screen. I rounded that to the third digit past the decimal. The derivative, the second derivative, is negative between this x and this x. Therefore, our graph is going to be concave down on the interval from 0.129 the rest of the way to 0.223. So here's where we are concave down. If we look at part C shouldn't be too bad because it's asking us to find the equation of a tangent line. And it's supposed to be tangent to the graph of g at this x. So we're going to have to start that by finding the slope of the tangent line at that x. And that's always going to correspond to the derivative evaluated at that x. And if I wanted to evaluate this derivative at that x, I already have my g prime function graph from part A. If I start my table at 0.3, when I look at this table, this y value right here, since I've graphed y1 as g prime, this is really the value of g prime when x is 0.3. So I know the slope of my tangent line is going to be negative 0.472. I could have found that by using the value feature from off the calculate menu as well. Now the next thing that we're going to have to determine is what the point of tangency is. And I picked this problem a little bit before we were ready for it. So I'm going to kind of talk about how we would find this, but you don't really have to worry about anything quite like what I'm about to do for the purposes of Friday's quiz. We will, within a week or so, understand why this needs to be worked out the way we're going to check it out here. I need to know what g of 0.3 is. I don't have g of x. I do know what g of 1 is. I know that when x is 1, my function value is 2. If I'm looking to find what g of 0.3 is, what I'm going to do is I'm going to start with my value for g at 1, which is 2, and I'm actually going to have to subtract off how much the value of g changed between the x of 0.3 and the x of 1. So in another week or so, you'll know why I'm working this out the way I am right here. I'm basically integrating the rate of change of g to figure out how much g changed between 0.3 and 1. So within a week, you'll understand this. Right now, I'll just kind of give you the result. If we wanted to evaluate this integral on the calculator, we could go with a lower limit of 0.3 and an upper limit of 1. And you'll see I already worked it out there, but I want the answer on the bottom of the screen. The value of this integral is 0.454 if I round that to the nearest thousandth. So 2 minus 0.454 is going to give you a value of g, and this is approximated now, so I guess I should use the right notation. And the value of this would end up being, let's see, well, 2 minus 0.454 should leave us at 1.546, I believe. So the value for g of 0.3 is 1.546. If the point of tangency is 0.3 comma 1.546, and this is the slope of your tangent line, the easiest way to write down the equation of that tangent line is to go to point slope form and do y minus y1. Well, that's the y coordinate that corresponds to this x, and that's what we just found. And then that's got to equal m, which we got from the table a little bit earlier, times the quantity x minus x1. And here would be the equation, or an equation of your tangent line at 0.3. And then in the last part of this should make some decent sense. It's not really something that we've discussed much this year, so if I can scroll up to it, we'll finally talk about it here. So it says, does the line tangent to the graph of g at 0.3 lie above or below the graph of g from 0.3 the rest of the way to 1, and why? So what we know is we know the equation of our tangent line at 0.3. And the equation of that tangent line at this x had a, if I click back to it, it had a negative slope, right? Yeah, we had a negative slope right here was the slope. So we had a negative slope, and the point of tangency was 0.3 comma 1.546. So if I wanted to try to draw myself a quick version of this tangent line, it would look something like this. I'm going to have a negative slope, and I have to go through the point 0.3 comma, so here's the 1.546 value. and that's supposed to have a negative slope. Now I'm going to make that slope a little bit more obviously negative just to make the rationale behind why we're about to answer the way we're about to make a bit more sense. So here's my negatively sloped tangent line. I'm going to go back to something that we got together earlier, and that was the sign chart for G double prime. I know that at point 3, which would be, right here within the sign chart, from point 3 to 1, the graph of G has to be concave up. So what I'm going to do on this graph is this is the tangent line from part C. I'm going to draw a graph that's concave up, extending outward the rest of the way to 1. If I need to have a negative slope for my tangent line, I'm going to have something like this. And if my graph's going to be concave up, that would have to mean my graph is cupped upward, meaning the slope of my tangent line is increasing as I progress across my graph from point 3 the rest of the way to 1. Because G is concave up on this interval, we know the tangent line is going to sit below the graph of G. This is going to be something that you're going to see pretty frequently in these free response questions. If you're asked to decide if a tangent line sits above or below the graph of a function, if you know what the concavity of the function is on the portion of the graph you're considering, you should be able to draw yourself a little diagram like we just did and then answer accordingly. So questions like this are almost always going to be answered by using concavity arguments. Since the graph's concave up and the tangent line has a negative slope, the tangent line is going to go below the graph outward to the right of the x value of 0.3.